Hey guys, in this video I'm going to go over a basic problem on Lu factorization. So before I go into how to solve this particular problem, let me go over what Lu factorization is and the different methods to solve it. So probably in algebra you learned about factorization, and with matrices it's the same thing. If you have a matrix A, you can factorize it into the product of matrices. So for example, if B and C are also matrices, you can do matrix multiplication of two matrices to get a matrix, and this would be considered the factorization of A. So some factorizations are more useful than others. The Lu factorization is when you take a matrix A and you factorize it into a matrix of I guess I should do the lower one first, a lower triangular matrix and an upper triangular matrix. So by that we mean that the lower triangular matrix has zeros above the main diagonal and the upper triangular matrix has zeros below the main diagonal. And the reason this is a special case of factorization for matrices is that it has special properties. Lu factorization is one way that computers get the solution to systems of equations. So not every matrix is Lu factorizable, or it's sometimes called decomposition. So you can't always have that a matrix A will equal Lu. And I'm not going to go into it in this video, but sometimes you need what's called a permutation matrix. And for every or any square matrix, you can do LUP factorization, where P is the permutation matrix and L and U are still the lower and upper triangular matrices. But I'm not going to go into that in this video, so I'm going to do an example, and this is an example of a matrix where you can do LU factorization. So how do you know if you need the P or not? Basically, you can do LU factorization for a matrix, and there are theorems for this, but the main idea for finding LU factorization is you're going to take the matrix that you're given A, and you're going to put it into row echelon form. Now, row echelon form happens to be, again, a special case of an upper triangular matrix. And then when you're making the steps to get to row echelon form, if you don't have to do any row interchanges, then you can do LU factorization. So basically, if you don't have to do any row swaps when you're getting A into its row echelon form, then you can do LU factorization. And I'll show you an example for this problem. So the way we're going to do the LU factorization the basic way, and there's also actually a shortcut that I'm also not going to do in this video, but you can look it up online. There's actually a lot of information on LU factorization. So this is just a basic video. So the method that we're going to do here is we're basically going to write out the different steps that we take, doing one step at a time to get A into its row echelon form. Then row echelon form is a type of upper triangular matrix. So this is going to be U. So we're going to have A, and then we're going to do for all these steps, so let's say we do row 1 minus row 2 or things like that, or 2 times row 3. These are all going to be rewritten as elementary matrices. So this will be E1, E2, E3. So we're going to have basically that A times E1, E2, E3, etc. is equal to U. Now there's a theorem that says that all elementary matrices are invertible, and there's another theorem that says that the product of invertible matrices is invertible. So we know that we can take the inverse of each one of these matrices individually, and we can also take the inverse of the product, because that will also be an invertible matrix. So what we're going to do is we're going to call this basically, we're going to call it, let's say, L inverse A equals to U, and then we can take the inverse of L inverse on both sides, and that will give us L inverse times L inverse of the inverse of L inverse, and then that will be L, that will be like that basically. And what that's going to do is that's going to cancel out, so that's going to give you an identity matrix, which is equal to just A, and on this side this will give you, actually this should have been written this way to be more correct, so that will give you A equals LU. So that will give you the factorization. Alright, so let me just show you doing this problem what I'm talking about. Okay, so we're going to take A, which is 1 1, 2, 3, 4, 5, 6, 7, 8, 10, and we're going to do the steps that will get it into row echelon form. So I'm going to write out all these steps and probably fast forward through this, and it doesn't matter how you do it. So since there are different ways to get it into row echelon form, as long as you keep track of your steps, then when you get to the end, it will work either way. It doesn't matter the step. So the steps don't have to be exactly the ones that I'm taking. Okay, so if we call this E1 for the first elementary matrix, E2, and E3, we're going to get that E3, E2, E1, A equals to the upper triangular matrix, which is, I'm just going to call that U, where U is, now I'm going to write out what each individual elementary matrix is. So E1 would be 1, 0, 0, negative 4, 1, 0, 0, 0, 1. E2 would be 1, 0, 0, 0, 1, 0, negative 7, 0, 1, and E3 would be 1, 0, 0, 0, 1, 0, 0, negative 2, 1. So now, similar to what I did before, we're going to say let L equal to the inverse of E3, E2, E1. When you distribute the inverse, that's going to give you the inverse of E1 times the inverse of E2 times the inverse of E3. Thus we can say A equals LU, where U is equal to what I had above, and L is equal to, actually let me write this out again, so that's 1, 2, 3, 0, negative 3, negative 6, 0, 0, 1, and L is equal to the product of these inverses. So that's going to be 1, 0, 0, 4, 1, 0, 0, 0, 1 times 1, 0, 0, 0, 1, 0, 7, 0, 1, and 1, 0, 0, 0, 1, 0, 0, 2, 1, which is going to be equal to 1, 0, 0, 4, 1, 0, 7, 2, 1. So this and this multiplied will give you A, and that's your final answer. And you do have to, there are a lot of steps that I did kind of skip, so I did kind of go over or glossed over how you do the inverses, but maybe I'll make a video on that, separately. And I also didn't go over how you find the elementary matrices. I'm kind of assuming that you guys know how to do that, but that is kind of the idea for basic LU factorization. I think I will make a video about LUP factorization in the future, but for now I'm just going to end the video here. Thank you for watching.